Hi students, this is AJ sir. Let's study 9th standard ICSE Math, chapter 8a, logarithms.
Now, if there is an equation that is 3 raised to 4 is equal to 81, that is the exponential form of writing it. If you want to write it in the logarithmic form, it is log of 81 to the base 3 is equal to 4. Note how the base here became the base of the log. The answer here, that is on the RHS, is now written on the LHS and we call it log of 81. And the power, that is the exponent, becomes the answer on the RHS. That is how we convert the exponential form into the log form. The general formula is a raised to b is equal to c is written as log of a to the base log of c to the base a is equal to b. Now, before we start solving sums, you may wonder, why do we use log? Why is it necessary to convert the exponential form into logarithmic form? Because in this entire chapter, we shall only practice the rules of using log. Just like we had rules of indices, if you remember, that is, in multiplication we add the powers, in division we subtract the powers, and so on. Here we will study the rules of log. But the actual application in day-to-day life is not discussed in this chapter. In fact, it's not a part of school syllabus because log is something used in advanced standards. It is used by mathematicians, engineers, and people of various fields when they want to simplify their calculations. Yes, simplify their calculations. In the absence of the computer or a calculator, when you are multiplying huge numbers or dividing huge numbers, log comes in very handy. Although you may wonder that we do have calculators, so why should we continue using log? Well, because it makes our logic strong. If you study computer science, it's all about logic. Let's take a few examples. If 2 raised to minus 3 is written as 0.125, this equation is correct because 2 raised to minus 3 is nothing but 1 upon 2 raised to 3, that is 1 upon 8, and that is indeed 0.125. So in logarithmic form we write it as log of 0.125 to the base 2 is equal to minus 3. So now that we know this, we can start solving. A few interesting observations. We know that x raised to 0 is equal to 1. That means anything raised to 0 is equal to 1. Similarly, log of 1 is always 0. No matter what the base is, it doesn't matter. Log of 1 is always 0. So remember this point. See here, log of 1 to the base 5 is 0 and even to the base 10 is 0. Also, we know that any number raised to 1 is always the same number. So we can say that log of any number with the same number as the base is always 1. For example, log of 5 to the base 5 is 1, or log of 10 to the base 10 is 1, and so on. So remember this observation as well. Now in exercise 8a, let's do 1.1. 5 cube is equal to 125. How do we write it in the logarithmic form? So log, the answer goes to the LHS. The base becomes the base of the log. And the power goes on the RHS. So that's how we rewrite it in log form. Next, in question 1.3, it's 10 raised to minus 3 is equal to 0.001. So in the log form, we will write it like this. Log of 0.001 to the base 10 is equal to minus 3. This is something new for you, so it will take time for you to digest this and get used to it. Now in 2.1, they have given the log form and they want us to write in the exponential form. That is a reverse of what we did in the previous sum. So this is a log form. How do we write it in the exponential form? If you remember, it's always the base becomes the base. This becomes the power. And this is the final answer here. Similarly, in 2.3, how to convert it into exponential form? It will be a raised to x is equal to a. In 2.3, the answer is a raised to x is equal to a. That's the exponential form. Third sum, solve for x. And they've given a logarithmic equation. Solve for x means we have to find the value of x. So the first step is to convert it into an exponential form. 10 raised to minus 2 is equal to x. And now it's easy to find the value of x. 10 raised to minus 2 is 1 upon 10 raised to 2, that is 1 upon 100, that is 0.01. So that's the value of x. Next, 4.1. Find the log of 100 to the base 10. Well, assume that the log of 100 to the base 10 is x. So now we have to solve this to get the value of x. Step number 1, convert this into the exponential form, that is 10 raised to x is equal to 100. Now solve this to get the value of x by comparing. I want the bases same, so this will become 10 raised to 2, and by comparing, x is equal to 2. And what is x? X is the answer for the log. So log of 100 to the base 10 is 2. That's the final answer. Similarly, 4.3 answer can be obtained by following the same method. First convert it into exponential form. We've assumed the answer to be x. So the exponential form is 10 raised to x is equal to 0.001. Now in order to compare, we want the bases to be the same. So 0.001 is 10 raised to minus 3 because this is actually 1 upon 1000. 1 upon 1000 is 1 upon 10 raised to 3. That is the same as 10 raised to minus 3 in the numerator. So I got the bases same, so the powers are same. X is equal to minus 3, so that's the final answer. Now Roman number 5, we assume the value of the log to be equal to x. So 2 raised to x is equal to 0.125, which becomes 125 upon 1000. After reducing, it becomes 1 upon 8, which is 1 upon 2 cube, which becomes 2 raised to minus 3 in the numerator. The bases are same, so the powers are equal, and so final answer is minus 3. You have to write the final answer. You can't stop the sum with x is equal to minus 3. Now mark 4.7 as IMP. We'll assume log 27 to the base 9 is equal to x. So you can even write here let in all the sums. Now I want the bases to be same. So that is why let's make it 3 squared. So this becomes 3 raised to 2x and this becomes 3 cubed. Now that the bases are same, we can compare the indices. So 2x is equal to 3 and x is equal to 3 upon 2. And then please write the final statement as well. Now true and false. If log of x to the base 10 is a, then is this true? No, it isn't, because the true statement would be 10 raised to a is equal to x. So write false. Write the answers in your numericals book, not in the textbook. But no need to copy the question. What about this? Well, in this case, if you want to convert this into a log form, it would be log of z to the base x is equal to y. So that's not correct here. So that's false. And here they have given two logarithmic expressions. There is no if in the third one. And there is an and. That means if either of them is false, the whole statement becomes false. So let's see if both of them are true. This is true, yeah, because 2 cube is equal to 8. And even this is true because 8 raised to 1 upon 3 is equal to 2. 8 raised to 1 upon 3 is actually cube root of 8. And cube root of 8 is indeed 2. Next, 6.1. Find x if this is true. Now in 6.1 and 6.3, we just have to find the value of x. 3 raised to 0 is equal to x. Now anything raised to 0 is always 1. That means x is equal to 1. And in this sum, again, in exponential form, first of all, 9 raised to x is equal to 243. I want the bases same. So this becomes 3 squared. And this becomes 3 raised to 5. So the exponents are equal. Hence the value of x is 2.5. Now in the seventh sum, again the same method. First we convert it into an exponential form. So it becomes 7 squared is equal to this. That becomes 49. Minus 1 goes to the other side and this becomes plus 1. 49 plus 1 is 50. 2 goes down, so 50 upon 2 is 25. Square becomes square root. So x is equal to plus or minus 5. That's the final answer. Now evaluate means we have to find the value of this. So we'll let it be x. So that 10 raised to x is equal to 0.01, which is 1 upon 100, which is 1 upon 10 raised to 2, and that is 10 raised to minus 2. Bases are same, so the powers are same. So the final answer is minus 2. With more practice, you'll actually start remembering the answers. Now 7.3 is IMP. We'll assume that log of 1 to the base 5 is x. Remember, log of 1 is always 0, no matter what the base is. Let me prove that. So here 5 raised to x is equal to 1. And 1 can also be written as 5 raised to 0 because anything raised to 0 is 1. I chose 5 because I want the bases same. That means x is equal to 0. So the final answer is indeed 0. Now Roman number 5, we'll assume this to be x. So 16 raised to x is equal to 8. I want the bases same. 16 is 2 raised to 4. 8 is 2 cube. So since the bases are same, the powers are equal. So x is equal to 3 upon 4. So write the final statement as well. That is, this is equal to 3 upon 4. Now in 9.1, they have given some logarithmic values and they've asked us to express 2 raised to m minus 3 in terms of x. So first of all, let me use the first logarithmic equation that they have given. So let me write 2 raised to m is equal to x. Now let me copy the question, that is 2 raised to m minus 3. Subtraction of powers means the division with the common bases. And 2 raised to m is x. And 2 cube is 8. So the final answer is x upon 8. Now mark the 11th sum as IMP. They have given an equation, we have to solve it and get the value of x. Now here we'll have to use one property which actually belongs to the next exercise. Whenever we have log of m into n, we can split it as log of m plus log of n, the bases being the same. So similarly, since here they have log of something plus log of another thing, we can actually bring the brackets together as a multiplication. That is a reverse of what we did here. So I can write this as a single log of this multiplied by this. That's one of the rules of logarithm. Addition of logs can be converted into a single log with the multiplication of the numbers. But this is true only if the base is same. What is the base here? The base is not even mentioned. Well, such logs are called natural logs, and whenever no base is mentioned, it is understood that the base is 10. So we need not write it because it is understood. Now on the RHS, the base is 2, by the way. However, we know that log of 1 is always 0. No matter what the base is, the log of 1 is always 0. So let me just write it at 0. Now let's convert this into an exponential form. So 10 raised to 0 will give me this as the answer. And this is actually a formula called x square minus 1. So the new exponential equation is 10 raised to 0 is equal to x square minus 1. But 10 raised to 0 is 1. Shift minus 1 on the other side. So you get x square is equal to 2 and value of x is plus or minus root 2. However, minus root 2 is invalid because inside the log I cannot have minus root 2. So the only answer is x is equal to root 2.